Hey, good morning, good afternoon, everyone. Nice to meet with you all today. This is a little bit of a kind of advertised as a bit of an AMA and a little bit of something that we wanted to share that we've been working on here at GitHub. For the 8+ years I've been working here, companies in various industries have been asking us in one fashion or another to help them contribute a little bit more comfortably, if not securely, depending upon the word we want to use here, to open source projects. And while the requirements varied a little bit from company to company and industry to industry, the overwhelming theme was we want some process in place to be able to review a commit before it goes live. And ideally, we'd like to be able to run CI or other sorts of tests against that before it goes live. And some companies have the ability to intercept all their network traffic, and some didn't. But ultimately, the goal was really how do we encourage even more broad participation in open source so that companies who are consuming all of these open source projects can be or become or be meaningful contributors back to those projects. We've had some fits and starts on this over the years, but our communities team, who I've got two members here, I'll let further introduce themselves. Eric Sorenson and Andrew Henry are here to share what we've been working on to start addressing that problem here over at GitHub. Eric and Andrew, y'all want to introduce yourselves?
Sure. Yeah, so I'm Eric Sorenson. I'm the product manager in GitHub's OSPO. And as GitHub's OSPO, we have an interesting kind of dual role where we're both responsible, much like many of you here are, for our own company's open source efforts and making sure that Hubbers that write code can release that effectively out into the world and that we can participate in upstream projects. But we also try to build things to help everyone that's using GitHub for open sourcey types of things, and particularly for folks that are in that position that Phil just described, where you're running and the funnel through which your organization's open source contributions flow, and we want to make that as frictionless as possible. So yeah, been for about 2 years. Prior to that, I was heavily involved in open source in the DevOps space. I worked as the product manager for the configuration management tool Puppet for about 8 years and was involved in for about a long time, about a decade before that, also doing large scale open source configuration management.
I'll take it away. Yeah, I'm Andrew Henry. I am a software engineer at GitHub's open source program office, and I build cool stuff. So I've been here probably a little under 2 years. And then before this, I was actually at Capital One's OSPO as a software engineer. So very familiar with the problem space and some of the solutions that we can apply to it. So very happy to be here.
This will be a very brief. I just have a couple of slides and I won't belabor the point because so Andrew and I have been talking to a number of our community members and customers about this project, and some of them have greater or less familiarity with the space and the problem space. Y'all are obviously pretty deeply embedded in it, so I'm not going to go through all of this, but I do want to, in great detail, but I do want to say that just as a framing for the type of problem that we're trying to solve, is that when we have these folks in the roles that I was talking about, the enterprise OSPOs, and particularly amongst heavily regulated industries, there's this difficult balancing act where we want the goodness of open source, but the compliance, legal, and security teams often have concerns that outweigh that desire. And when there's a direct conflict between those two, the conservative approach often will prevail. And we're trying to get to a more balanced approach where we can both achieve the benefits of participating in upstream open source and balance those out against the very real risks. We're not talking about FUD, although there is a certain element of FUD that tends to be introduced there. But we're largely, people are concerned about leakages of various kinds, whether those are personal data, intellectual property to the company. An extremely common thing is to have secrets be leaked. This is something that we've actually built into GitHub itself to do secret scanning, because we've seen OS keys be exploited to spin up cloud resources by Bitcoin miners and other nefarious interests within minutes of them being published to public GitHub. So there are some real risks here. We want to be able to balance that out. Unfortunately, and frankly, GitHub makes this harder than it necessarily needs to be because of this requirement. This is from the GitHub docs about how forking repositories works. And right at the top, it says that it must share code, a fork shares code, and importantly for our problem, visibility settings with the repository that it's forked from. And in order to take advantage of this fork network, as it's called, this keeps things in sync and allows some amazing benefits that have enabled tremendous scale copy on. The downstream forks do have to have the same visibility as that upstream repository. It's hard to keep the private stuff private. The user problem we're trying to solve could be stated as like, how can I keep working, or how can I keep my work that's going to an upstream project private until it's approved to be made public? And the tool that we've made that addresses this, that we're walk through in just a minute, is called internal contribution forks. It's a bit of a mouthful of a name, so I've made this handy short link, gh.io/ICF, if you want to check out the repository. And under the hood, it is a standalone Dockerized app that has a web front end, and it will create n private mirrors that map to a public fork of an upstream project and manage the synchronization of those respective mirrors back up to their public, the fork that they're associated with, so that once they're approved, made public on the private side, you can then go through a regular pull request type process and engage in the upstream community, feeling safe and having a verifiable audit trail that all of the internal measures were met, that it went through appropriate reviews. And so before there were any commits that were made public. And this has the nice benefit of being able to do things like, if a secret, for example, is introduced in the private side and then deleted, you can use the squash history feature and remove the traces of that, so people don't see a commit that adds it and then a commit that deletes it. That's all completely squashed down before that chain set is made public. And this is a bit of a time sequence diagram that's from the docs that we have online, just to give you a bit of a walkthrough of what we're going to do in the demo. Just as I mentioned, there's a public project that we're forking into a public fork, and then the app takes responsibility for the center and the right-hand columns here, which manage the public fork, and the private mirror, which have those protection rules, has those protection rules on it. We've had an extension for people that are using emus. An emu, if you're not familiar, I think I and Phil especially would be envious of you if you don't know what an emu is, because we spend a lot of time dealing with them. But they are enterprise managed users. These are users in a special kind of GitHub instance that is forbidden from interacting with public GitHub. For example, once you're inside an emu account, you can't even comment on an issue or a discussion. You can view things, but everything outside of your emu organization is in read-only mode. And a lot of organizations do this. Going back to the FUD, there's a lot of FUD around that, but this does allow you to keep your users closely tied to your internal identity management system and that sort of stuff. So it's an appealing option for a lot of organizations. And we have the ability to have those private mirrors exist inside of an enterprise managed user organization, but have a corresponding public organization where people use their public GitHub identities, and have the linkage between those two managed by the app, which we'll show in just a minute. And with that, like I said, I would be very brief. We will dive right into a demo. I'll stop sharing and hand over the reins to Andrew.
Yes, like he alluded to, this is gh.io/ICF. Welcome to our public repository. This is all the code that we're currently working on, and I would like to do a little scene setting for all of you. I'm actually going to pull up that diagram once again. There's two ways that you can operate this. Like he said before, you can either operate in a single GitHub organization that lives on github.com, so you do all your work in a public space in private repositories. We found that a lot of organizations do have emus and they do want to use them. And we have since adapted the application to be able to support emus. When I talk about emus, just so the terminology is clear, that means a GHEC instance where your enterprise manages your users, and then your account has read-only mode. I'm just going to throw that out there. A little bit of scene setting. We have a project upstream that we want to contribute to. We have a public organization, so this organization is under your control. This is where all your public forks live. And then you have an emu organization. This is where all your mirrors live. Another thing, you do have to have two personalities in this case. And so I say personalities, I really mean accounts. Phil will be more than happy to talk about how to manage those later in the AMA. But in this case, I do have two accounts. I have one account for my public GitHub personality or persona. So when you see this very handsome fellow up here in the corner, that is my public GitHub account. So this is what I use to interact with github.com and other collaborators and create issues, aka not emu. But yes, the flow is relatively exactly the same. If you are doing a single organization instance, you would only have one account. So you don't really have to worry about this. But for those using emus, you get the extended cut. Sorry, Director's Edition. Cool. Once you see this cute fellow down here with the pink red smiley face, that's my emu account. Cool. Let's get started. So I'm going to show off the two orgs. If you were using a single organization flow, you would have this public GitHub org. That's it. And you don't have to worry about emus at all. And so this organization is where all of our public forks live. And then this organization is where all of our emus live. This is managed by our emus. And so this is where the mirrors will live for this organization. And so with that, let's contribute to primer design. So this is GitHub's component framework, and this is their design library. I contribute to it pretty frequently, but I don't want to do it in the open. I want to do it in a managed way so that I can have someone on my team approve it. So let's do it. We leave this flow up to the implementing organization. I will say you do have to get a fork to exist in your public forking org. How you do that is completely up to you, and whether you allow users to do that or if you just have a process to do that. Again, we don't have a stance on that. You just need to make sure that a fork does exist in your organization, because that's the only way to contribute upstream on GitHub. As I said before, we use a GitHub app installed on both of the organizations or on your single organization that manages all of the elevated permissions and actions that a user can take, while they themselves have no permissions at all. So as part of that, since I do have admin access on this org, I can show you what happens behind the scenes for someone that might not have access. So we do have branch protections right now. We are going to be moving to rule sets relatively soon, but the branch protection that applies to every fork created in the contribution org is that for every branch, we require that no one can push to it except the application, except the GitHub app. This allows it so that users themselves cannot push to this and expose any code publicly without going through the GitHub app to perform that privileged action. It's a little caveat I like to point out there and how we manage some of this control and access. As part of the GitHub app, one of the things is this can't be in the product. This flow right here is something custom to us. And when you sign into your public GitHub profile on our application here, you are presented with a list of organizations that the GitHub app is installed on. So in this case, this is the contribution organization. And then list all the forks that you are allowed to create mirrors for. So since I just did design, I'm going to create a new mirror for design. So there are no mirrors found for this fork, and I'm going to create mine. So in this case, when I create a new mirror, this will create a new repository. So these have to be unique in regards to the other repositories in your organization. So I spelled my name right. And we let the bot do all of the repository creation. Like I said, your users themselves would probably have no permissions in this case. Now, since I am in emu mode, this went and created a new repository over at our emu org, which is GitHub osmo test-emu. If we were to open this up, you would see that we do have limited access because of our enterprise management. And so here we have our entire repository cloned over into the organization where we do mirrors. Like I said before, if you were using a single organization, this would exist alongside the fork, just as another private repository. And so to save you all the trouble of seeing my messy desktop, I'm going to be making a contribution via the UI. And actually, before I do that, let's show some of the access controls that we apply to mirrors and why this flow works pretty well. So unlike a fork, we only provide a branch protection rule that applies to the main branch of the repository. So we expect users to do a trunk-based workflow where they work off of branches and then merge them in as they are feature complete and approved. So we leave this flow also configurable to the organization. So you can add whatever checks and workflows that you want here. For demo purposes, this is a very simple workflow in that we only require another approval from someone else in the org, which in this case will be my esteemed colleague, Eric. And so with that, let's finally make a contribution. And I'll show why we allow anyone to create branches and then only the main branch itself is protected on a mirror. So if I were to come in here, actually, let's do something fun here. So go to ICF. Boom. Commit changes. I can't commit to main because it is a protected branch. Commit message looks fabulous. And then I'm going to do update readme as my proposed changes for my branch name. So I'll come in. I made my contribution, pretend I did a bunch of Git magic. I was working with teammates for weeks. We now have a PR that we want to open from our development branch into the main branch of the mirror. So you can see all my changes here. I create a pull request. So now this is all happening in the confines of a private mirror, either in your emu org or in your private GitHub org alongside the fork.
Point out that here's the point at which if you had additional policy checks. So right now the protections are just, they make sure that there's another reviewer and they make sure that the CI test that we have to ensure code quality have passed. But if there are additional checks that you wanted to add for internal policy, for things like license checking, for adding dependencies with incompatible licenses, any additional policy checks could be added here as conditional pass-fail tests, like you would a CI test. And all of those happen inside of the private space as well.
Absolutely. Yeah, I think the biggest selling point here is that you can see all of my changes privately before they are ever entered into the public space, which is fantastic. And then from there, like Eric said, you can build upon and add your own checks as required. So license checks, CLA checks, whatever you really need for your organization. So we got this fantastic stamp of approval from alternate Pook. And so finally, I, as a user, can come in and merge my pull request. So now it might seem a little odd that I'm merging a pull request on a private repository that I own, but let's explain why. So here's where the magic happens. So we can see here the main branch of our private mirror has now been updated, and it now has the commits living in the main branch. So if I were to come back into the original fork into our public organization on github.com, and I switch back to my personality, which is my public GitHub persona and what I use to interact with GitHub. If I were to come into here, you'll notice that a new branch is created, and that branch is actually the name of the mirror. And then if I were to come into here, magically, there are 2 commits ahead of primer main. And so you can see that my user has now made 2 commits, both of which have been verified because they were using GitHub's UI. And so there's a signing key in the background. And then if we look at the changes that are made here, we can now see that all the changes that happened in the private space have now appeared in our public fork. And with that, we can hit this magic button here called contribute, open pull request, and boom, you now have a pull request that happened in a private space in your own organization. And you can now make a contribution as if you were on GitHub. And bada bing.
Thanks, Andrew. We're pretty excited about this and the things that it will ideally allow for a lot of our customers to do to start opening up additional contributions. The goal here is not to be competitive with other solutions in the space, things like Git proxy and other solutions like that, because we recognize some of our customers don't have network control over their developers. And we also recognize that there are times when you might want to run a complete repository check, a CI check, other things like that on the proposed contribution, which this enables. If anything, for users who are using something like Git proxy already, this could be a complementary solution where Git proxy manages from an outbound network layer what the individual developer is allowed to interact with. And we can use something like an internal contribution fork as a way to run more extensive policy checks and other things on that actual commit before it ever gets surfaced to the open source project. Any questions about this project before we open up a general forum?
I've got a quick question.
Yeah.
You were talking about squashing commits. So let's say on my private emu mirror of the project, I accidentally commit a GitHub secret or like my password or something. And then when I go back into, and then obviously somebody picks that up and it fails like a check, I write a new commit and fix it. Is there any way of controlling the fact that commits need to get squashed when pushing back to your public organization?
In the actual repository settings themselves, you can select which type of merge is allowed for any of those within kind of the repository settings that Andrew was showing. We skimmed over that, but Andrew, you have the repository settings screen up where we can show a require squash merge?
I believe so. Let me check.
Sure, it says yes. You can. There's a policy setting that you can require that every.
Yeah.
Let's see. In general, even if it's not a secret, this is frequently a common setting or a common configuration pattern for people, because a lot of times even if it's not something sensitive, there can be back and forth in the PRs, additions from things that were either private APIs that they were touching that turn into public API, or other things that might be low-grade information leakage, or even just low-quality code, for example, that had to go through extensive code review. And a lot of folks, even in the pure open source world, want to see those commits squashed down before all of that internal back and forth is made public.
Yeah, it's somewhere in here. There is a setting for it.
It's settings, general pull requests, and then it goes under squash merge.
Oh, I see. Settings, general pull request.
Right here. In this one, this would be a policy that as part of the automated setup of the repository, we could just choose which of these types of merge commits are allowed. So if we wanted to only have that single squash commit, we'd get rid of the merge commits. So the merge commit wouldn't have shown up there on those two commits in that pull request. We would only seen the one. And then we could get rid of rebase and just say squash everything and only squash it. So if you didn't want to go through and continually edit your commits and force push over the top of them, squashing would clean it all up.
I don't have this great demo. I don't really have anything too specific. It was a really good demo though. It's cool to see how mature this has got. One question I did have was around propagating the developer ID, so for attribution, right, basically. So what happens in the case of, like, I guess the EMU case? Like, what happens in that case?
Sure.
Yeah.
Do you want to start with this one, or do you want me to?
I was going to say, this one there's a couple solutions, but Phil can probably list them better than I can.
So in actuality, like I joked with Andrew a little bit that a part of me dies inside whenever somebody wanted to do this completely in the enterprise managed user space, because ultimately the developer still has to open up a pull request with the community and interact with the community maintainer as their open source identity. And the internal contribution forks kind of standard workflow that wasn't shown still requires that private repository out in the space. So the only real difference in the EMU space is that I'm creating the commit in the private fork as one identity, and I'm interacting with the community as another identity. That said, we could still do that flow. However, the attribution ultimately comes down to email addresses. And if the email address of your EMU identity is associated with your public GitHub identity, that commit will still be mapped back to that individual developer for as long as that email address is associated. So if at some point the developer removes that email address, they go on and work somewhere else, that commit history would be lost. But if the organization allows that developer to contribute to that private copy using their github.com identity, then those commits stay around with them as long as they have that email address associated.
And Phil, just a quick question as a follow-on. Because we're juggling two identities here, things like GPG keys would just have to be shared between those two things, right? Because I would presume in the emu case, you really can't have that identity linked together today because they are separate.
Or you do a git config -user email and put your github.com identity in when you create that commit logged in as your emu user and have the GPG key there. That's where things get fuzzy, where we can technically support it, but you are correct, we'd be looking at two different identities. That's why the community side advocate within me really says we should really bias ourselves toward letting the developer use their public identity in order to create that private commit, keep that key associated with it. We still can enforce that workflow. If you're a GitHub customer, we can even put an SSO gate around contributions to those private repositories in that open source repository. That's a conversation we can have apart from this, which is more kind of account management-y, salesy stuff. But we can put an SSO gate around the use of that public identity. That's actually what we do internally here at GitHub. Anytime we sign into the GitHub organization, which we don't use the enterprise managed user bit, GitHub just lets us bring our own handle to work. We still have to sign in against our Okta implementation to do anything.
Yeah, it's interesting that you folks went the repository route, because I think this solution is a little bit more flexible. We essentially did the sort of the branch-based flow with an internal repo with just like branches that then get mapped to like our public fork. And I think the maintaining the history between internal sort of development copies and external forks before they go out is like something that we're grappling with, and like how that collaboration workflow works is a little bit tricky. So I actually think ICF has a bit of a more cleaner approach, because I guess my question would be, is the intention that every developer who is queued up to be a contributor would have their own repo, and that sort of gets mapped back to the public fork?
You can think of it as it's a mirror per contribution, because the mirror gets mapped to a branch. So then if for data records and retention purposes, like once that is accepted by the upstream, you could archive that repository. You could choose to delete it if you wanted to. You could do whatever you need. That contribution repository is gone, and that developer has another contribution. They create another mirror. And then any of those policies that are out there, the weird thing about policies is if you've got like configuration files in the repo, suddenly the configuration file in the parent's a little different than the child. But one of the things that we can do out in GitHub would be to require an organization-wide or like an organizational actions workflow, and basically configure that job or that actions workflow for at the organization level, and say, run this policy check against all repos or against these repos. And that way we get rid of the need to have a configuration file actually sitting in the repos themselves. And it just gets automatically applied when every mirror is created. And as always, it's an open source repo, so PR is welcome.
Yeah, and even as a lower sort of barrier, if you don't feel like diving in, we'd love to hear issues and a question back to the community too, is if, as we're thinking about additional this policy types of checks, like the requiring squash merges, are there other things that you've either implemented internally or would like to see out of the box in the app that would help enable this for use in your organization?
Also, lastly, we are providing a hosted version of this that you can use if you want to, or you can go deploy it yourself and create your own copy of the app anywhere you can run a Docker container. The nice thing about the app is we actually don't store any data. All we're really doing is just running a couple of commands. And you can see everything that's going on in there. So if you want to play around with it in our installation, you can. If you want to use our installation, great. If you feel a lot better about it running somewhere in your own infrastructure, on your own Kubernetes cluster or anything like that, go for it.
Earlier in the call, you were talking about how finance didn't use emus, or that didn't seem to be a thing.
Well,
why is that, Phil?
I know that a number of the member firms on the call right now are either using a solution other than GitHub for managing their internal code, or if they're using GitHub, they might be using our self-hosted deployment. The enterprise managed user is all about providing a similar level of control over the user management for companies who are going to manage their enterprise code in our SaaS environment. And a number of the firms who are doing that have made requests for us to try to extend this kind of internal contribution forks to that identity model. If you're using GitLab or Bitbucket or GitHub Enterprise Server, EMU stuff doesn't necessarily really apply. It was about making that bridge for those folks who are already out in GitHub in our kind of enterprise user model.
And I guess just to follow on there, Phil, the same sort of model would apply if you have an external SCM host, right? Because ultimately those private internal forks have to target something, and it seems like you folks have support for like an enterprise cloud tenant using EMU as well as a public organization.
Correct.
Yeah.
Yep. Correct. It's got to all stay within a flavor of GitHub.com, just because we need to move the stuff back and forth, and the APIs have to work on both sides, all that good stuff.
Makes sense.
Happy to take any other random questions, not at all related to this too. We've got the time.
Actually, one thing I missed was that you have two organizations, right? An external public organization and an internal, like a private EMU organization. How does your app know the name of the EMU? Maybe I missed that step of you've used the app to clone or to mirror the repo from the public organization, but how does it know the EMU organization?
Great question. So the way that we do it, you can either operate in two modes. You can operate in single organization mode, like we said before. So that's where you have a single organization that you do all your contributions in, both the fork and the mirrors. And so if you operate in that mode, you're allowed to have as many organizations as you want. The app just has to be installed on that organization. The other operating mode we call single instance mode is where you have an app that is installed on both your public contributions org on github.com and your EMU org. In this case, you can't have more than those two. That is configured in a deployment via environment variables. So environment variables, you give them the name of your organizations that exist in both, and then install it on both, and then it knows what to do. One caveat, if you do that, you will have to host the app yourself. Now, if you were using another hosted version, like a GitHub hosted version, that would be single instance mode, where you can install it on your own app and then, or on your own organization, and then have the controls there.
And the single org mode mirrors a lot of what we've seen, at least outside of finance, do in terms of managing their open source presence, where, you know, even if they're not using GitHub for source control for their internal code, they'll go and create a public organization, and they'll have all of their forks on there, and they might have some private code on there too for collaborating with external entities or for stuff that they're not ready to quite make public yet. And this is just building on that pattern where we're using the private side of that organization to hide all of the stuff that's not ready to be seen yet, and then that approval workflow to go ahead and lift and shift it and drop it over into the fork. The difference here is, where are we lifting and shifting from? Are we lifting and shifting from a private repository in the same org or a private repository in a different org?
A very succinct answer, direct answer to question two, is that there's a little configuration file that has that mapping. And additionally, we recently had the ability to include in that configuration a list of usernames which are allowed to access the app. By default, anyone that is a member of the organization can go into that web interface that Andrew showed and create a new mirror for themselves. If you want to lock that down and restrict that to just certain folks that can create those mirrors on behalf of the users, or perhaps certain people only certain people allowed to work on some projects, that sort of thing, you could restrict that list to administrators. It's not a super sophisticated access control mechanism right now, but it does allow you to pare down the list of folks that are allowed to interact with it. And that is also configured inside of that little simple environment file.
I guess that's an important point, and I suppose it's very early days, but I guess things like integrating with Active Directory for that type of role management is that in there, or is that a backlog item?
There's a couple of questions that I'd actually have on that one, Ridian. So we could potentially look at mapping it to a GitHub team, and we can map those GitHub teams back to an IDP using kind of stuff that already works off the shelf. But then ultimately, I'd like to understand the root of the concern too, right? Let's say that you still need to, if the app is enforcing an approval from the OSPO office before anything can be made public, is the fact that a developer can go in and kind of mess on something privately and still have to go through that approval path, is that something that absolutely needs to be guarded and blocked against an IDP group? Or is that a degree of freedom that's okay to have because there's still only one way to make that public, which is to go through the blessed process?
So I guess there's a couple of things there, Phil. So one would be it doesn't scale if like enterprise-wide for large organizations. Think about like minor bug fixes, which is you're just going to delegate approval and review of those sorts of things down to the people who actually know it, not the OSPO. Like the OSPO just never going to do it. How big is an OSPO? Like it's never going to be big enough. It's not going to scale. And the second thing is who's guarding the guards. Like you all organizations like ours have that type of like also entitlements checks things.
So if the question was the question about being able to assign a group of reviewers to an IDP group versus who can go and propose changes to the code, or was it both?
It's both, yeah. And then so who can contribute, who can review, who can approve, those sorts of things.
So we can handle about 2/3 of that right now out of the box capabilities built directly in. We can handle who can approve, and we can tie that to a GitHub team, which can be mapped to an IDP group today. So that as long as you're using either Okta or Azure Active Directory / Entra ID or whatever it's called now, or Ping, we can map that back. We can also assign rights and permissions to those individual repositories as they're created to particular groups. We might have to do a little bit of tweaking to the app to make the automation work, but the base permissioning system within GitHub can be tied back to GitHub teams, which can be tied back to IDP groups. The thing that's a bit of an open question on that is access to the application itself, like who can go in and create a mirror. That's not something that, at least today, that we can tie to an IDP group yet.
Just have a random question because we encountered this on our our script that basically does the same thing. But how do you folks have a way for ICF to keep the upstream in sync with the public fork? Because that was one thing that we found, like, as our contribution internally has a longer tail, it's very hard to continuously rebase and keep those two things in sync. So I was just curious if there was like a mechanism to make that more in sync with what like an open source upstream project might have going on.
That's a great question. Yeah, that's something that we're trying to work through. We leave that up to the developer to pull in changes on their mirror. So at any point, I can always push to a branch and have my mirror updated. And regardless what happens, the Git histories will still line up. So whether the fork is out of date, my branch on the fork, if I include the changes from upstream, will not be. So we avoid that problem.
Thomas, was your question about keeping the mirror or about keeping the public fork in sync with the upstream?
It's more the public fork, because so today we just do like an API call and like a background task that we just run continuously throughout the day. And it would just be nice to have it integrated into the same GitHub app, because then I can keep that flow like directly from upstream, create the public fork, create the internal, and then keep it flowing both directions.
I see. Yeah, okay. That's fantastic feedback. We will actually...
I can open an issue if it's not in there.
Please do. Yes, please do.
Will do.
Keep me accountable. Great question.
Phil, do you feel okay for you to share contact with the people, something that they can reach you from? So if they have more questions, there might be questions too complex, too specific to an environment that they don't.
Sure. If the questions are public, we have issues and discussions enabled on the repo itself. So that's a great way to get in contact with me, but more importantly, Andrew and Eric, who are shepherding this project at GitHub. And if it's something that you'd prefer to ask in a little bit more private forum, you can certainly reach out. I'll drop my email in the chat here. But my email is also, I believe, on the FINOS website in a variety of places as well. So please just feel free to reach out.